Children who have loved science from a young age play with water in a unique way. By popping a balloon underwater the moment it bursts, it simulates a spectacular mushroom cloud-like scene. Place a half-filled oral liquid bottle upside down into a large beverage bottle filled with water, then tighten the cap. At this point, you can increase the pressure by squeezing the outer bottle to change the volume of the remaining air in the small bottle, thereby controlling the sinking and floating of the small bottle. This is the principle of how fish sink and float. How can you pour out a full bottle of water as quickly as possible? Simply rotate the bottle a few times before pouring, which will create a water vortex inside the bottle. This way, pouring the water can save half the time. This is the principle of the water vortex. Cover one end of an empty straw with your hand, then place the other end into the water. At this point, simply release your hand, and you will find that even an empty straw can successfully draw out the water. This is the siphon phenomenon caused by the water hammer effect. Drop a few drops of blue and orange dye into two separate cups. Fill the blue one with cold water and the orange one with hot water. If you invert the hot water over the cold water and remove the card in between, you will see that the 2 cups of water remain unchanged, with each staying in its own place. However, if you reverse the setup and invert the cold water over the hot water, once you remove the card in between, the result is completely different. The 2 cups of water immediately mix into another color. This is the phenomenon of thermal convection, where heat rises and cold sinks. Sprinkle pepper on a plate filled with water, and it will float evenly. If you dip your finger in some dish soap and touch the center of the water, you will see the powder spread out in a regular circular pattern. This is because the surface tension of the liquid is broken. When you pour relatively pure clean water into a tank and shine a laser pointer through it, you will see that there is almost no clear light path in the water. If you add a little milk to the water and stir it evenly, you will see a straight and clear light path in the water. This is the Tyndall effect. If you continue to add more milk, you will find that the light has difficulty penetrating situ. This is the principle of how heavy fog affects visibility.